Hello everyone, welcome to our lecture number 2. So let's start the class. First we study the post PC era. The post PC era referred to the time after personal computer, which we call PC, stopped being the main computing device. Instead of this PC, we use smartphones, tablets, cloud services become the primary tools for accessing the internet, apps and data. It emphasizes mobility, touch interfaces and constant connectivity over traditional desktop setup. It's mean updatation of computer. First set we have desktop, then we have smartphone, then we have smartwatches. So this is the updation of computer system, and we call this the post PC era. So let's go to the next topic, how touch screen work. In this 2025 we all know about the touch screen because we have experiences about using touch mobile phone or touch smartwatches. Yeah, also most of you know about the touch screen laptop. So how this touch screen work? Most screen use capacitive touch. Your finger changes the electrical field on the screen. The device detects where the touch happened by sensing the change. Uh, we all know that in human body there is some electron, some proton flow in our body. So there is some charge in our hand. There is some very little, but there is some charges. Sorry if this hand is look like very horrible, but understandable. When you touch a skin, with these electrons touch also the skin, so this capacity sense these electrons and the motion of touch, so it's take user input. For example, in a computer you use uh, keyboard and mouse for a input. In touch screen we use touch for user input. How LCD screen display image? So how this screen display us image. So the screen made of tiny square called pixel. Each pixel show a color based on a bit pattern stored in memory frame buffer. Now what is frame buffer? Think of it as a grid of values bit pattern stored in memory. Each value controls the brightness and color of pixel. For example, uh, pixel, let's take x-axis and y-axis. For example, this is our monitor. This is our monitor, and here is x naught and y naught, and here is x1 and y1. So the value of x naught y naught is 0 0 1 1, which indicate light shade, and for value of x1 y1, which is 1 1 0 1 1 1 0 1, which is darker shade. So these two type of pixel show output in different way. First one is light shade, second one is dark shade. So this value is stored in buffer memory, this frame buffer. The value is stored in frame buffer in a pattern. So you can imagine that all this value is stored, and it's represent the requirement of our display, or show us the required image or photo or file where we're searching for. So this is the way that it's work. Display process: the system scan the frame buffer row by row. raster scan, and lights up the pixel accordingly on the screen. Sorry, accordingly on the screen. So how it's scan? For example, this is our display. It's scan like this. Start from here, then go there, there, and in is here. So this is the line how it's scanning. It start from here and in from here, and it scan all the display. Now talk about CPU, the brain of a computer. What's inside the CPU processor? Data path. It's the part that does the work like math, add subtraction, moving data. Example, it adds two number or send data to memory. So data path is important. Another is control unit. Data like a traffic of our brain inside the CPU. It tells the data path what to do next and when. Cache memory also important. Tiny super fast memory close to the CPU. Its mean is near to the CPU. This is our CPU. And hold recent or frequently used data on the CPU does not have to wait slower main memory. It's help us to memorize previous memory. Memorize previous or recent memory for CPU. When CPU needs it delivered to the CPU so that it process can be faster. Previous memory. So data path is just like for example you can say we take x and y, two value, and we have to multiply these two value. For example 5 and 10, and we have to sum this value, then we get 15. So data path is 5 and 10. And what is control unit? Control unit is I command here for sum. So CPU get me the output of 5 plus 10, and we find out the result is 15. So this is the process how CPU work. We find more details about CPU in future classes. So now talk about volatile memory, main memory or RAM. We all know the full form of RAM, random access memory, fast but temporary. Obviously, it cannot store data, but when it when the device is on, the RAM is processing the memory and stored the memory. Loses everything when the power is off. Use while the computer is running. So that is the characteristic of RAM. Now let's talk about non-volatile memory. Secondary memory, also we can call ROM, which can store data permanently. Keeps data even when the power is off. Used to store files, programs, and the operating system. SSD, fast, no moving parts, like a big USB stick. Sorry, big, like a big USB stick. Optical disc, CD, DVD, with SSD look like this, and CD, DVD is look like this. Now this is very rare in present time, CD, DVD, because it's now backdated. Uses laser to read and write data because the read and write time is very lengthy, and SSD is more faster than this CD, DVD. Magnetic disks, hard disks, store data using spinning metal disks and magnetic head. So this hard disks look like this. There is a magnetic for collecting data, and there is a plate which is rotating. So that's how hard disks work. The more faster uh, hard disk is faster than CD and DVD, and SSD is faster than hard disk. So if we can write this way. HDD hard disks, and for more better, we use SSD. It can write and read more faster. Let's talk about analog circuit. Work with continuous signals like sound, light. Use component like resistance, slow down current, inductor, store energy in a magnetic field, capacitor, stored energy in electric field. Analog signal is just like this. It's a continuous signal. And digital signal work with 0 and 1. It's on, otherwise it's off. Use transistor to switch and control the flow of electricity. Transistors are the basic building blocks of computer. Transistor. This is very important because it's help to build processor. Transistor. We use transistor for building a processor. Now talk about semiconductor technology. Semiconductor material like silicon. They allow some electricity to flow. Not too much, not too little. Used to build transistors and chips. Conductor. Materials like copper and aluminum. Lets electricity, heat, sound and flow easily. Insulator. Material like plastic or glasses which stop the flow of current. Current can flow between insulator. Block the flow of electricity. Yes. Very low conductivity. Yes, definitely. Capacitor. Made by putting an insulator between two conductor. It's a look like this conductor, conductor, and there is a insulator. Can store electrical charge like a teeny battery, tiny battery. Semiconductor. If you visualize this as a semiconductor door that opens halfway, conductor wide open door, current can flow easily. Insulator locket door, current cannot flow from here. Capacitor water tank, storing pressure between two pipes, store electricity. Now talk about MOSFET. What is MOSFET? A MOSFET is metal oxide semiconductor field effect transistor. So that's also a transistor. How it's work? It has three main parts. Gate, this is gate, and source, this is source, sorry, source, then drain, where current goes out, source where current came in, and where current, oh sorry, where in source current came in, mane the current is enter from here, enter from the source and out from the drain. It's basically say about this. And drain where current goes out. Yes. Control the switch. This mean gate is just like a switch, control the flow of current here. If you use the red marker, this is, it's, the switch is connect here and is control on and off. When you apply voltage to the gate, it's open the path between source and drain, allowing current to flow. Yes. Why it's important? MOSFET are the building blocks of modern electronics. Billion of them are used in CPU, memory and power circuit because this is a transistor. We already talked about that. Transistor help to build processor or CPU. let's talk about two types of MOSFET, NMOS and PMOS. NMOS and PMOS transistors serve as the backbone of digital circuit. PMOS lower power consumption. CMOS lowest power consumption. Lower power consumption and lowest power consumption. So open when NMOS or N type, open when voltage at G is low, close when voltage G is high. And PMOS or P type, close when voltage at G is low, open when voltage at G is high. So this is look like work opposite of each other. So let's talk about the logic gate. Most of you already know about logic gate. It's AND gate, OR gate, XOR gate, NAND gate, NOR gate, and XNOR gate. AND gate basically it's multiply. If we multiply 0 0, then we get 0 0 1, then 0 0 1, then 0, then 1 1 and 1. And OR is work like a summation 0 0 0 1 0 1 0 1 1 1 1 1. And XOR is similar type data, then output is 0. And this is the exactly opposite of AND gate, which is NAND gate. You can see the output here. These are opposite. Also same. This is the opposite of OR gate, which is NOR gate, and this is the opposite of XOR gate, which is XNOR gate. So this is very easy. So go to the next topic. Sequential circuit. What are sequential circuit? Circuit that remember things. They use past information called state to decide what to do next. Key feature: memory element. Use things like flip-flop. You know that there are lots of type flip-flop: JK flip-flop, T flip-flop, D flip-flop. I draw a flip-flop here so you can understand. This is a clock, and this is output input. This is controlling unit. So they remember the last result or step. Next state depends on past. The same input can lead to different output depending on what happened before. So it can store previous memory, and anytime and it's use the memory to get the output. Example, for you can, if you don't clear the topic, if you follow the example, I definitely assure you that you can clear the topic. Like a traffic light controller, you know that the traffic light controller, I think you all definitely know traffic light, how it's work. It's let's say red color, then black color, then we don't have green color, so we use this. So this look like a traffic light. Pressing button might turn the light green only if it was red before. If we have red, then after that we get green, otherwise we don't get green. And if we have green or black, then we get red. So that's the way it's work. Same button press but different result based on past state. So it's analyze the previous data for getting the output, present output. Flip-flops, units of memory. Flip-flops simply explain. A flip-flop is the smallest unit of memory in digital circuit. It can store one bit, either 0 or 1. We use clock. Basically we use clock for this use. The clock give 0 or 1 into the logic gate, and it's help to make decision. made from logic gates. Yes, remember its state until told to change. Think of it like light switch. It's either on, either off, and it's stay that way until flipped. Memory types. We already talked about that volatile and non-volatile. Now talk about memory types, which is RAM and ROM. RAM is a random access memory. There is two types of RAM: DRAM and SRAM. DRAM is a dynamic RAM, need, needs a result. Sorry, needs regular refresh to keep data, slower but cheaper and denser. SRAM, static RAM, no refresh needed, fast and more reliable but costlier. Talk about ROM, read-only memory, MROM and PROM. Programmed during manufacturing, just like firmware, cannot be changed later. For example, your router, the firmware already set up it in your router. So after this setup, you cannot update it or manipulate this framework. So this is MROM, and PROM can be programmed once by the user, just like BIOS setup. For your for example, you use your computer and your computer is set up it first is set up it in BIOS, then it's set up it the Windows. So in BIOS setting we set up one time, data is stay permanently after programming. Manufacture of IC. So this is very important. uh, if we simply talk about that, how to manufacture a IC, so it's use basically sand, look like sand. Let's we go to a Sahara desert, and this is sand, which is sulfur dioxide, SO2, and we need silicon for manufacture sand. So we collecting sulfur dioxide or sand, then we use heat. After heating we find out silicon silicon. So it's a silicon oxide. I write sulfur dioxide, silicon dioxide. After heating we find silicon. For example, if we find this silicon, it's look like cylinder, then we cut the cylinder. If we slice it from here, then we find a circular shape, then we polish it, then polish polish. After polishing we find a circular things, it look like this. And we let's cut it from here, then we use uh, some technology and use this as a CPU, and company manufacture them for a CPU. So basically the CPU is come from sand. So thank you, that's all for today. See you in the next class, and if you give me some instruction, you can write in the comment box. Also you can give me some suggestion if you want. You are very welcome. And if you have any confusion in this lecture too, you can write it in the comment box. I will try to answer it as soon as possible. So thank you everyone, and stay with us. Goodbye.